so it's always important to focus on the setup that the author is giving you, because a lot of times you don't need to know what X or Y is in order to know what X times Y is. So we're being asked, is X times Y even? And that's what I want to consider first, because how does that happen? Well, X times Y is even if you have, for example, 2 times 2, you get 4. So even times even is even. Or 2 times 3 is 6, so even times odd is also even. But 3 times 5 is 15, so odd times odd is odd. And so basically, if you have an even and you multiply any other number, you always get an even. But the only way to not get an even out is to have odd times odd. So as long as X and Y are not both odd, then this will have to be even. So if either of them is even, this whole thing has to be even. Either even times odd, or odd times even will give us an even answer out. Statement 1 says 5x minus 4y is even. Well, 4y is always going to be even because an even times anything gives us an even. Now 5x has to be even because in order for us to get an even number as an answer, which we're told that we do, we have to have even plus or minus even to get an even answer out. So even minus even, 4 minus 2 equals 2, 3 minus 2 equals 1. So odd minus even equals odd, even minus even equals even, which guarantees that 5x has to be even, which means that x has to be even because we have an odd number times something equals even there. And that means x has to be even to keep that number even. So we're testing a bunch of little number properties things, all about even odds, either addition or multiplication or subtraction. And you just need to test them out using intelligent numbers if you don't know the rules. But basically, statement 1 guarantees that x has to be even. We don't know anything about y because 4y will always be even. We can't learn anything about y from this. But we know x is even, which means this will have to be even as well, because even times y is guaranteed to be even. Once you introduce a multiple of 2 into an equation, 13 times 17 times 25 times 2, that's now all an even product. But before it was odd. Once you put one even number into the mix, it becomes even forever until you divide by 2. So that's just an interesting thing to think about. But statement 2 here, we have the same sort of situation. We know we're getting an even answer out, and we know 6x is even, which means we have to add an even number, which means 7y is even, so y must be even. This on its own also tells us x times y is even, because x times an even number will also give us an even number. So each of these statements is sufficient on its own, and that is answer choice D.